I've created an Arduino-powered RC transmitter that I'll be using to control my Hexapod and all my future projects. And in this video, I'll be teaching you step-by-step on how to print, solder, assemble, and code your own. The controller communicates using an NRFl01 Transceiver chip, so make sure any projects you plan on controlling also have that chip. And there are a ton of inputs that you can use to control those projects, including 4 bumpers, 4 toggles, 4 buttons, 2 joysticks, 2 potentiometers, a rotary encoder, and a gyroscope. There's a 2.4-inch screen, and Arduino Mega Pro as the brains, all being powered by a replaceable 9-volt battery. If you want to build your own, I'm selling a kit that contains all of the needed components. You can buy the kit from my store at the link in the description. So without further ado, let's get started. The files for this entire project can be found on my GitHub. The link is in the description. Let's start with printing the STLs. Go to the GitHub repo, click STLs, and you'll see all of the STLs. These are the individual STLs, and we're not going to be using those, although they're there if you want them. Go into groups. And okay, so now we can go 2 separate routes. The first one, and the one I would highly recommend if you can, is by doing the everything file. It's a .3mf. So if you can open that, then you should use this one. So try this one first. Click it, download. There it is. And I'm going to open it. Okay, and you'll see that it opens 5 separate plates. Now, each one of these plates corresponds to the remaining 5 files in here. Button springs, cap parts, case back, case front, handles plus battery door. So if you can't open this .3mf file, then you're going to have to individually open the remaining 5 files, which again correspond to each of these plates. I'm personally using 3 Bambu Lab P1Ps with PETG filament and a 0.4 millimeter nozzle. You can go lower than that. Obviously, it might take a while though, but if you want to go higher than 0.4, maybe 0.6, 0.8, you probably can on everything except the caps and screen spacer and the button springs plates. Those you need to use at least a 0.4 millimeter nozzle. Now, you might be wondering, why not just place everything on one plate? You can definitely fit it. I highly recommend separating them because if you shove them all on one plate, the print will probably fail, or at the very least be of lower quality. So you really should print these 4 things on their own plates. So now let me just go over my advice for printing these 5 plates. Let's start with the handles and battery door. Super easy print. I would recommend gyroid 7%, and actually that's what I'd recommend for literally all of this. Now let's take a look at the case top. Not a super difficult print, but an important one. This is the front of your controller, so you don't want it to look bad. If you have adhesion issues, or if your printer tends to have adhesion issues, I would highly consider either a brim, or if your printer supports it, adding brim ears to specifically this corner and this corner. So now if we slice, this is what it looks like. These sharp corners tend to raise. A brim would do the exact same thing, except these are much easier to remove. Now let's take a look at the case bottom. This one is quite a bit more difficult compared to the top and the handles and battery door. One, you'll need supports. So if I click this and then go to objects, you'll see how I already have supports enabled. The battery door overhang, the USB-C overhang, and then the 2 bumper overhangs should definitely have supports. If we slice, you'll see how they're all supported. It can print without them, but you should definitely use them. The other thing is these 2 corners want to lift really badly. So the way to get around that is first, make sure you have good adhesion. Clean your plates, do whatever you need to do. And then also add a brim. Either a brim, or this slicer supports brim ears. Some call it like mouse ears. You're able to just add a brim in specific spots. And obviously we want to do these corners. I'm going to go a little bit more than just these corners. You'll see how there's only a brim around the around the spots that give an issue, that cause an issue. And of course, I still have gyroid and 7% and infill, and this looks like that. And finally, the last plate for the main color is the button springs. Do not print these in the other color. You want this to be the exact same color as the case top. So the button springs, relatively simple. This print is very delicate. You really want to print this slowly. It's very important that you're slow on, frankly, the entire print, but at the very least, the initial layer. I would recommend lowering the initial layer to either what I have or even slower, to be honest. Do what you need to do to get these to print. This is probably the hardest part to print in the entire thing, so take your time with it. And that's why they're on their own plate, because if they mess up, it's super easy to just run it again. The spring should be separated from the center part. And finally, the caps plus screen spacers. The screen spacers don't really need to be this color, but I just threw them on here. So I would highly recommend making these a different color from the rest of the controller. You don't have to, but it definitely looks a lot better that way. These are also quite delicate, not as delicate as the button springs, but delicate enough to where I would recommend lowering the initial layer speed to be quite slow. You'll see like these buttons have lettering, and if we slice, this is not easy to print. The one thing that you do most likely need is a brim around the joystick caps. We do not have that at the moment. If we go to others, brim type auto. Yeah, I mean, auto recognizes that it needs it. Otherwise, these probably will pop off. If you have any questions or need help on printing any of this stuff, feel free to leave a YouTube comment or join the Discord and ask for help there. Once you've got the 3D printed parts printed, the next step is to solder all the components onto the PCB. If you're new to soldering, I would highly recommend learning how to solder in a different video before trying this. This is my setup. They're called Soldering Helping Hands, and I'll link mine in the description. Before we start soldering onto the PCB, I'd like to quickly mention the PCB sponsor of this video, PCBWay. PCBWay offers a variety of different services, their main one being PCB fabrication. For these, I wanted to try their matte black option, and of course they turned out perfectly. They'll also be manufacturing the PCBs for the kits, and I have no doubts about how they'll turn out. Thanks again to PCBWay for sponsoring this part of the video. Check them out at the link in the description. We are going to start by soldering the 4 push buttons to the top of the PCB. They can only go on one way, which is like this. Okay. And then we're going to flip it over and solder these 4 points. And we're going to do that for each button. The next step is the Arduino Mega Pro. So it's really important that we do this in the correct way. I have already done it wrong. So I soldered the pins onto it. The problem is I am unable to get this to fit. I tried bending the pins. I'm just going to show you the correct way to do it. And that is putting the pins in first and then soldering it with the pin, like while it's in the PCB. So again, the short side of the pin goes through the PCB like this. Okay, so with the pins in, we can put the Arduino Mega Pro onto the pins. Now solder the pins to the Arduino Mega Pro. This is probably the hardest soldering, like the most difficult soldering of the entire project, because the pins are super tall. So it can be hard to like get the soldering iron like down in there. So for this at least, I'd recommend using a thinner point. It's looking good. The next step is to actually solder the pins onto the PCB. The next step is the potentiometers. One goes here, and this one is easy enough. and the other goes here, but it doesn't fit. And that's because these potentiometers have little plastic like pillar nub things on the bottom, and we just need to snip those off. You just need to cut that and that. Once you cut it, it can fit perfectly. Here's what that looks like. It's really important that these are straight up. If they're not, you won't be able to put the caps on properly. I mean, same for the joysticks and the rotary encoder, but for these, it's a little bit more difficult because they can like easily tilt. The next step is the female header. So that goes right here. Again, make sure it's soldered straight up, but for this, it's pretty easy to bend it if it's not perfectly straight. Female header is soldered on. This is what it looks like. The next step is the power switch. You can see these little symbol, the little O and I symbol, and that corresponds with the O and I symbol on the power switch. So it goes like this. This can be a bit difficult to solder because there's just a lot more metal to heat up. The next step is the gyro. So the pins go in like this. The short end goes through the bottom of the gyro and out the top. The long pins goes in there, and then we're going to solder the long pins on this side. The next step is the joysticks. Right? So those go here and here. These are pretty easy. They sit pretty flat. The next step is to solder the NRF chip. So that's going to go on the back right here. And we're going to solder the pins here. And here's what the NRF looks like. Let's do the toggles now. So they go up at the top, solder it on the top, and make sure they're attached straight up. Otherwise, that might not fit in the case. The next step is going to be soldering on the JST connectors, specifically the female ends, which are these. We're going to have 2 on the top for bumpers 1 and 3. So it'll go here and here. The orientation does not matter, as in like you can have it like this or like this. It does not matter. And then those are gonna just fall out. We're gonna have 2 more for bumpers 2 and 4. So it's gonna be the bottom ones that go on the bottom. It's gonna go here and here. And then the final one is going to go, that's for the battery. It's gonna go right here. So this one, the orientation also doesn't matter, but it does matter if you want the plus for the battery wire to be red. To make sure that is the case, we can just plug it in like this. And then we see that this side is red, so we want the orientation to be like this. Okay, for that 5th one. We've got our JST connectors soldered. The next step is the rotary encoder. So that goes right here. Make sure it lays flat, but this should be relatively easy. Here's the rotary encoder, soldered on. Next, we're going to do the resistors and the capacitors. The capacitors go on the back, right here, and here. The orientation does matter. So the white part is negative, and the not white part is positive, and there's a little tiny plus sign you can see as well. And on the capacitor, you see the white part is negative. So match up the negative part with the negative part like that. The capacitors are soldered on. The pins are there and there. Now let's do the resistors. The 2 resistors on the back are right there, and then the 2 on the front are right there. The resistors are now soldered on. We've got 2 right there, and then Here's the pins of the two back ones. That's it for the PCB soldering. There is one more thing you need to solder though, which is the bumpers. We need to solder the wires to these pins, to the bumper pins. We're going to be using the two left pins. We're going to be using the two pins on the same side that the lever arm connects to. Before you do solder, we're going to want to trim these wires. They're a bit too long. Two of them just do full length. Two of them do slightly longer than half. Here are the bumper wires. Too long, too short. Looking good. And that is it for the soldering. With everything soldered, it is time to assemble it. We'll need the 3D printed parts, a 9-volt battery, a Phillips head screwdriver, a hot glue gun, and a soldering iron. We'll start with the heated inserts. So there are 10 of them, 6 in the bottom case and 4 in the top case. Heat your soldering iron to around 350, and we're going to put the smaller end of the heated insert into the hole. This is one of the holes. Here, 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 and here are the 6 for the bottom case. Put it in like that. And then using the soldering iron, you just basically shove the soldering iron into it and then slowly push. So do that for all 10. For the top case, by the way, it's here, 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 and here. That is the heated inserts inserted. The next step is to attach the battery contact springs using the 6mm M2 screws. Here are the 6mm M2 screws. They're the silver screws that are shorter than the other silver screws, and there's only 2 of them. And then here are the battery contact tabs. So what we want to do is take our screwdriver. Let's make sure that the screwdriver can actually screw the screw. It can, that's good, it's the right size. They go here and here. Put the tab like that. It kind of stays on its own, which is nice. Let's put the screw on it and kind of just, yeah, there we go. There we go, okay. Okay, so I just tightened it pretty much all the way. It's a little loose. We don't want it to be tight all the way though, because we need to slide the this wire under it. You'll see. Yeah, something like that. So we can kind of lift it up a little bit for now. That's what it looks like. The next step is, it's important that you get it right. So it's going to be attaching this to the springs. So grab your PCB actually and flip it over. Okay, so this thing is going to be plugged in here. Positive on top, negative on bottom. We plug it in like this, and red's on top, black's on bottom. That's good. The red gets hooked on the right. The black gets hooked on the left. We left these tabs loose so we could slide the wires from this part under them. Like that. I'm going to do one at a time. And I'm going to hand tighten it. It's important that you don't over tighten this. It's good. Okay. Now, okay. Obviously, you'll be able to just pull this out if you pull hard enough. Don't do that. The reason we're not soldering it is purely because there's a lot of metal here to heat up, and it's pretty difficult to get the solder to stick. You can try, of course, but yeah, that's my reasoning for that. It might be smart to strip more of the
wire coating off so you can shove more of the wire under the tabs, but I mean, this is fine. We can actually test if it works. What I mean is like we can put the battery, hopefully you have a 9-volt, plus on the right. And this, so if we flip this power switch with everything plugged in and stuff, it should turn on. And it did. We've already uploaded the code and stuff, so yeah, I mean, that's the Rotary encoder. There we go. So yeah, everything actually works. If it's not working, it's probably best that you don't continue to assemble everything, and you should probably figure out why it's not working. It might be the batteries reversed. You might have not uploaded the code. It's possible you soldered something wrong. So now that it's working, I'm gonna turn it back off and continue assembling everything else. Next, we're going to do the bumpers. We're gonna need these 4 things, or actually just 2 right now, sorry. The two long wired ones, all right? And 2 of the bumper caps, which look like this. And finally, your hot glue gun, okay? The bumper caps slide onto the bumpers. There's a little hole that you can put it in. This might not fit perfectly. It might like be too loose. For me, it's actually perfect, which is nice. But if it's too loose, you may need the hot glue. Cool. Yeah, that's actually perfect. Okay, so with the bumper caps on the bumpers, we're going to screw them in. Oh, yeah, that's right. You need the 10 millimeter M2 screws as well. So it goes right here and right here. You want the part you press in to be towards the center, okay? So you're pressing it like this. It's really important that you do not over tighten this because again, it's being screwed in directly to the plastic. So once you start feeling resistance, stop. Now there is one more screw, but I am just testing it and it is perfect. It's not getting stuck. I can press it as hard as I want and it's working. So let's screw the other one in. Okay, it's screwed in. It's looking good. Now we do that for the other side. The next step is to plug in the 3 JST connectors and then attach the PCB. So let's do it. The battery one, as we already went over, goes in the center. This one, the left bumper goes here. And the right bumper goes here. Perfect. Now place the PCB in its spot. So this wire can get tucked in here, and this wire can just go wherever. Okay, and the PCB should fit into the case. Anyway, once it's all the way in, we can take 2 M3 screws. These are the black screws, and we can screw it in here and here above the power button. There we go. Okay, cool. Okay. All right. It's screwed in. Let's test it one more time just to make sure we didn't mess anything up. So plug the screen in, turn it on, and it still works. That's great. Time to install the screen. This is super easy. We've got the 2 screen spacers. Place those here and here. And then plug the screen in here. Make sure the pins are aligned properly. It's pretty easy to like misalign it left or right one pin. Let's do the other bumpers now. Just slide the bumper cap on. Use hot glue if it's too loose. And then screw it in here and here. All right, the bumpers are screwed on and working perfectly, so let's plug them in. It goes on like this, and this bumper gets plugged in here, and this one here. Okay, and now we can actually attach the top case to the bottom case. There's a slight issue here. It might be the wires, but it might be something else. I'm gonna try to figure it out. Okay, I fixed it. I just bent them inward like a lot. Again, you really should not have to do this. I'm gonna be moving this in so this does not collide. You will not have this issue, but I just wanted to show what I did to fix it. Now let's do the caps. So we've got the potentiometers, the joysticks, and the rotary encoder. Rotary encoder, notice how it's not a circle, so there's a specific way it gets attached, like that. Same thing for the potentiometers. There is a specific way it goes on. What I like to do is just put it all the way in, spin it all the way to the left, and then kind of just keep spinning and pushing until, you know, you can actually attach it. And the joysticks. Then these will definitely need hot glue. Notice how like they just come right off. So what we're gonna do is a dab of hot glue at the top. And that should, you do not want to do too much, but that should be enough to, just so they don't like literally fall off. You still want to be able to take them off just in case you want to replace them, but so now they don't just come off when you slightly pull them. Now let's do the button springs and the buttons. The idea is they get shoved into here. You probably won't be able to use your fingers, maybe your fingernails, but I would highly recommend like a a blunt tool so you're able to like press in the two tips of it. And you're actually compressing the plastic. All right, and it should look like this. It should not just come out. And you should also be able to like press it in with your finger at this point, and hear it clicking. That's the actual button being pressed. For this top one, we can put the A button, and you should be able to just press it in. Now, if you pull it slightly, hopefully it doesn't come out, but if it does, just do a dab of hot glue to keep it in. And just repeat that for the next 3 buttons. So here is what it looks like from the side, from the top, and it's looking good. 2 more steps: attaching the handles and then the antenna. Let's do the antenna because I always forget to do that. So you just shove it in and screw. It's pretty easy. Okay. And finally, the handles. There's no right and left. They can go on either way. So you just put them on like that and then screw in the 4 M3 screws. This is what it looks like. Let's do this side now. Now it actually feels good to hold. And if you haven't yet, put the battery in, plus on the right, of course. And power it on and pray that it actually turns on. And it does. Awesome. We should actually check if it, connects to the Hexapod. We can set it to, I think it was Hex01. Now, if I'm wrong about this, I'm going to have to check it in the code, but I'm going to check the code really quick. Okay, so it was actually Hex01. I believe for this to take effect, I have to turn it off and back on, so let's do that. And let's turn the Hexapod on. Hey, it's connected. All right, so we know it's connected because the legs are like, out. All right, let's check the offsets. Okay, so the offsets, we've received the offsets from the Hexapod, so that's working. Yeah, so it works. It's connected. Okay, just for some reason the Hexapod isn't walking at all. So I don't know why that is. I think I figured it out. Well, I hope I figured it out. The sleep delay is -1, so it's always sleeping. Okay, and now it is 1,000, which is 1 second. Yeah. Okay. Now it's actually working.
With the controller working, let's go over the code. But if you want to build a deeper understanding of things like programming, or if you just want to learn something new, then you should check out this video's sponsor, Brilliant. When I'm trying to learn a new skill, it only really sticks if I actually do something with it. Memorizing just doesn't work for me. And this is why I love the approach Brilliant is taking with teaching. Brilliant lets you learn by doing, with their thousands of interactive lessons in math, science, programming, and more. Instead of just following instructions, you'll actively work through challenges that strengthen your ability to think and problem solve. And by learning a little bit every day, you'll keep reinforcing and building those skills over time. Brilliant makes this easy with short, engaging lessons you can fit into any schedule. If you're into Arduino, robotics, or electronics, which you probably are if you're watching this channel, you'll inevitably want to write custom code for your projects. But if you don't know how to program, this can be daunting. Brilliant's programming and computer science courses are the perfect place to start. They'll help you build a strong foundation in coding, and you'll learn how to think like a programmer by breaking down complex problems into smaller, more manageable ones. There's also an entire course on Python, which is an excellent first language to learn. To try everything Brilliant has to offer for free for a full 30 days, visit the link in the description or scan the QR code on screen. You'll also get 20% off your first year. Thanks again to Brilliant for sponsoring this video. The link to this GitHub repository is in the description. There's 3 programs here. I would highly recommend downloading all 3 of them. We've got the Hexapod code, the generic code, and then a receiver example that communicates with the generic code. So download those 3 projects, and they're platform IO projects. And then we're going to open them in, platform IO. So I have platform IO installed on Visual Studio Code. It's an extension that you can search for. If you don't have it or you don't know what you're doing, I would highly recommend following a tutorial. This is not that tutorial, but it's this, okay? I'm gonna remove one of my examples so I can show you how to open a project. Okay, so I've removed the receiver example, all right? Now we're going to go into the platform IO, tab. I think it's gonna start. When you first install it, it starts like down here. I like putting it here. But anyway, open the tab and then go to quick access and then open. All right. So this is like the main home screen. From here, we click open project. All right. So I stored it. Where did I store it? Right here. So here's the, I've already opened the code Hexapod and code simple. It's already in my workspace. So I'm going to open this one. So I click on the folder and then, click open. Now let me show you how to upload code to the controller or any Arduino. Make sure it's plugged in. Then you need to make sure you're like on the right project. Click here and then click one of these. So I have 3 projects open and I personally want to upload the code simple. Right now I have the Hexapod software. I want to upload code simple. So I find the default code simple, which is here. Click it. Doing that makes the code simple program the active project. And then once it's the active project, click this button right here, upload. One of these tabs oh, here we go, terminal, yeah. And there you go. So the code is now uploaded and you can see that it is working. This is the simple code that I wrote. It displays all of the different outputs, including the joystick locations. Gyro's a little weird, but I think the Arduino doesn't run fast enough, but whatever. And then a simplified menu where you have the controls page, which you can, press any control, and then the settings page. And there's a single setting, which is the NRF address, which is all you need. Now, I said that the simple receiver example would communicate with the simple code example. And it just so happens that I have the simple receiver example installed on this Arduino Nano, which has an NRF chip hooked up to it.
and it is connected to this little hexapod leg. I have the position of the leg. It's hard to do this with one hand, but I have the position of the leg being controlled with the joysticks. All right, so I mean, as you can see, the controller is controlling my random Arduino project. Totally random. Along with the joysticks controlling it, we also have the first toggle putting it into calibration mode. So now the joysticks don't control it. And we also have this leg talking back to the controller. You see the little Wi-Fi symbol. That means it's connected. Like if we turn it off, turn the leg off, it disconnects. Plug it back in, and then it's reconnected. Now let's go over the code. I'm going to teach you just enough to be able to, actually change the code so you can control your own project. I'm not going to be going over the Hexapod code at all, but I highly recommend you installing it to your controller and then just like messing around in it and seeing if I did anything in it that you want to do for your code. I will be going over the code simple and the simple receiver example, but not line by line. Again, just enough so you like actually understand it. All right, let's start with like the big picture. So big picture, let's go into code simple and then NRF. Controller code is sending a data package to the receiver. This is that data package. The controller code edits the data in that package, sends it to the receiver reads that package, and then does stuff. In our case, it reads the joystick values and then moves the leg accordingly. The receiver has its own data package called the ACK data package or acknowledge data package that gets sent back to the controller every time it receives the controller's data package. In this case, the ACK data package, all it does is send whether or not it's connected, which is a little redundant, but I'm doing this because if you want to send more data, it's really easy to just add things that you can then use. These data packages, like this is the most important part of using the NRF. So it's important you understand like what's going on here. The max size of this package is 32 bytes. In our case, I believe this is 8 bytes. Yeah, this is just 8 bytes. So we have more than enough room. The joystick X and Y values take up 1 byte because that's a number from 0 to 255. And then the potentiometers also take up 1 byte. And then everything else is just a bit. So like the buttons, for example, it's just on or off, 0 or 1. So all it takes is a bit, super small. And then we group it up in groups of 8 bits to make like groups of bytes, right? So obviously this is just 1 byte, 1 byte. This is all 1 byte. This is all 1 byte. The reason we do this is just to make absolute certain that you're not going over the 32 byte max. All right, so we've got our data package. When is it sending? Like when does that actually happen? Oh, I'm actually in the simple receiver example. Whoops. Let's go into the controller, the code simple controller into main. Okay. This is the code that just gets continuously run. We're doing 2 main things. We're doing the UI stuff, the controller stuff. And then if we don't do that, we're sending the NRF data. Now this controller stuff runs every 100 milliseconds. You can change that, but that's what has worked best for me. So every 100 milliseconds this runs, and then if it's not running, we send the NRF data. What are we actually doing in this function? Well, if we go into it, it's literally this one line, radio.write RC data. RC data is our data package, okay? So this is a variable that is our data package, and we are sending it to the receiver. After the data is sent, we're checking if there is an ACK payload, an ACK package from the receiver. If there is, we update our ACK data variable. So we have the the RC data variable, which is the RC data package, and then we have the ACK data variable, which is the ACK data package. Remember, it's just one thing, one Boolean, which is whether it's connected or not. So we read this. So this variable gets updated with the data we read, and then this controller uses that data. In our case, let's go to the home page right here. So ACK data dot connected. If this is 1, if this is true, we draw the Wi-Fi symbol. If it's false, it means it's not connected. We draw the the disconnected symbol. Where are we actually setting the RC data? Oh, I don't think I said this yet. So in main, whatever the current page is, that page's loop runs in every 100 milliseconds. So when you're on the home page, when the home page is the current page, its loop function runs. All right. At the top of the home page's loop function, we're setting the RC data's, values. All right. That should give you like a decently good idea on kind of how this is sending data. Now, how do we receive that data? Frankly, you really don't have to touch this code, the controller code. You probably will have to alter your project's code, though. And by probably, you definitely will. So let's go into that. This is much, much simpler. All right, it's literally just 3 files. It's the main NRF and then the NRFh file. So let's look at the NRF.h first. This has to have the exact same data packages as the controller code. It needs to be exactly the same. Go into main, actually. Here's the loop. It's literally just basically it's alternating between 2 things. Moving the leg, reading the data. Moving the leg, reading the data. That's it. And then here, you see where RC data, it's the same variable. We're getting the joystick values, and then we're moving the leg accordingly. What matters is how you're reading the data. So, I mean, it's literally just RC data dot, and then you've got a bunch of different values. This is every value on the controller except the rotary encoder, I believe. Although you could add the rotary encoder if you wanted. Where is it actually being set, though? So, like where's the value being set? It's being set here. Not this. Right here. Radio.read RC data. This is reading the data from the air, and it's like from our controller, from the signal, and it is updating our RC data variable, which then is read from, which I just showed you. If you want to add this code to an existing project, all you need is the NRF.h file and the NRF.cpp file, and you'll need to include the NRF.h file to wherever you need the data. Obviously, make sure to call setup NRF. And then because you're including the NRF.h and because we're making the RC data and ACK data variables external, you will be able to just access the variables in your code. Let's go over some of the UI code and how that works. I've reloaded the Hexapod software onto the controller just so I can show you some of the features. We've got a multiple choice pop-up. We've got a main menu page that's scrollable. If we go to settings, we've got a settings page that's dynamically created. We've got a number pop-up, and we've got a string entry pop-up. And we've also got different a paging system. So we have breadcrumbs at the top, like we're on the stats page, we go back, now we're on the menu page, we go back, we're on the home page. There's a whole paging system. And then if you're on a certain page, that page's code is the only code that's running. So I'm gonna go through kind of like how those features work and how you can implement them for your own controller's program. Okay, we're back in the code simple controller code. If we go to main, let me go over the paging kind of system first. So each page gets its own file under the page folder. All right. If we go into include and then page.h, you'll see that each page has a base class of page. So they're all of class page. Current page, that variable is a page. Where is the class page? I believe I have it set here. Yeah, right here in globals. Page, current page. So whichever page is set equal to current page, that page's loop is going to run. That means that, for example, in the main menu, it's really easy to change the current page. You just set current page equal to the page you want to be the current page. For the main menu, remember we had just two pages, right? Two options, the settings page and the controls page. So right here, we just check which one we're hovering. Hovered is just a number, 0 or 1. And when we press the rotary encoder, it sets the current page to whichever page we're hovering. Let's say we selected the controls page. Now we're in the controls page. How do we get back? If you press A, current page equals the main menu page. It is super easy. So that's kind of how the page navigation works. How do you make a new page? You might want to make your own page. Well, first, I would recommend copying whichever page is closest to the one you're going to make. Okay. So like copy and paste that and then edit the, like the names of things. Obviously, you cannot name it the same name. And then we're going to go into page.h. You need to make a new class for your page. It needs to have these two functions at the very least, loop and init. If you have any variables, you can put them here. I think I'm trying to remember why these need to be here instead of like on the actual page. I think my best guess, since I put the hovered variable here, I think this value is like saved even if you leave the page. I wanted it like when you go back to the page, it remembers what you were previously hovered on. I think that's why you would want to put a variable here as opposed to, for example, here. Okay, but anyway, once you make your page class and your page file, your page CPP file, there's two more things you have to do. Let's go to globals first. So you go to globals.cpp and you create your page object, your page variable here. And then finally we go to globals.h and we add and we make it external. And it looks like we also have to declare the class here. C++, I don't like C++. Once you've done all that, you now have your page that you can set to the current page and access. It's worth noting that the init function gets called once you open the page. Every time you open the page. And here's where that gets called. If it checks the previous page, if the current page does not equal the previous page, it calls init. Okay, but anyway, that's how you make a new page. It's a pretty important thing to do if you want to like actually change this controller UI. So hopefully that made sense. The pop-ups are another pretty cool thing. What's a good example? I'm going to go back to my Hexapod code, okay? And you remember the gate pop-up on the home screen. That's like the best example of this. So in the homepage loop, I check if the B button is pressed, and if it is, open pop-up, in this case, open pop-up multiple choice, returns a number, okay? Int, it returns a number. So you call this function, and then can we actually go to it like full screen? Yeah. Okay, we call this function, and here it is, okay? Open pop-up multiple choice. Does not matter how it works. All you need to know is that when this function is called, it continuously runs without calling the NRF code, by the way. You're stuck in this loop until you make a selection. And then once you make a selection, it returns that value, whatever you selected. It returns that number, and then the main page, the page loop can continue running. So let's get out of the Hexapod code because it's a little bit different than the code you're going to be using. We're going to go to pop-up. So here is the actual pop-up code. You really shouldn't have to edit this. Let's go to the popup.h. So here are your options. This is kind of like what you have to work with. Multiple choice, number, like like the user can like type in a number, and then string. With multiple choice, well, with all three of these, you have a header. The header is like the text at the top. Like, for example, the header is selected gate. And then for the multiple choice, we have choices. This is an array of strings. These are the choices you can scroll through. It dynamically creates the list. There are pills that you can scroll through. You've already, I can just show you. So this list is dynamically created, and they're just little pills that you can, I say pills, they're just, options that you can scroll through. You don't have to worry about formatting or anything. And then the number of choices, this is a super fun C++ thing you're forced to do. If for some reason I can't tell how many things are in this array, so I have to specifically tell it. And then hovered. So this is what's initially hovered when you enter the menu. For the gates, in the case of the gate selection, when you enter the pop-up, the thing I want hovered is what's already been selected. It's the current gate. Now, you might not want that, so you probably should just put this to 0 if you just, because you probably want the first thing hovered each time. Yeah, so you call this function, and then it returns a number, and that number is which choice was selected. For the pop-up number, still has the header. You have the starting value, and then the minimum and maximum value. Everything else is taken care of. Actually, I mean, I might as well show that too. Let's go to, I think it's in, settings, and then sleep delay. So this is the pop-up number. These cannot be changed, although, I mean, you can change them if you want, but not easily at least. And then we have the number on the right. I am making the initial value what the value you set is. But again, you could just set it to whatever you want. Okay, and then finally, the pop-up string. Let's just go to it. So the NRF address is a great example of that. For this one, we just have header again, which the header in this case is NRF address and NRFaddr. We have the string initial value. In this case, it was what I had previously typed in. And then the string length. If the length is greater than, I think, 6, it will let you scroll. You can actually like scroll it. But you don't have to you don't have to code any of it. Like you literally just call this function and it returns what the user types in. This is essentially like a mini framework. Finally, the last thing I'm going to go over is the settings page. This is another pretty important thing to understand. So if we go to the settings page, you do not need to look at any of this, okay? All you need to understand is this, okay, at the top. To add a new setting, literally all you need to do is add another item in the settings array, and it will dynamically create the item in the settings list and the pop-up for the setting, okay? So
there are 3 settings types: Boolean, which is like yes or no, on or off, integer, and string. In our case, for the code simple, there's just one setting, the NRF address. Let's just add 2 more, okay? So copy and paste this. We'll call it, what the heck? We'll call it number test. And I mean, what else do we need to do here? So we have this. This is a setting, right? This is what we're creating. We start with the name, which is just a string. The setting type. Well, what's that right here? Okay, setting type. Next, string, Boolean, integer. I said number test, so we're gonna do oh my god, integer. Okay, what's next? The value, right? This is the variable that the setting will change. Okay. In this case, NRF address is stored here. So yeah, we're going to just go int number test equals 0. That's fine. You don't have to equal it to anything. Okay, number test, and it needs to be a pointer to it. I don't know. Just don't worry about it. Okay, just have a little ampersand before it. That's all that matters. Okay, and then because it's a number, it looks like the string also. Okay, so yeah, it's for integers or strings. Because it's a number or a string, we need a range. I mean, theoretically, yeah, you need a range. In our case, let's make it from -10 to 10. Okay. And we need a comma here because this is a list of things. That's it. That is literally all you need to do to add a new setting. It's even easier to do a Boolean test. Boolean. That's it. Oh no, sorry, that's not it. So we need a variable, of course. Bool. Yeah, there you go. That's it. There you go. We've just added 2 more settings. You don't believe me? Let's upload the code. Make sure, so we're on code Hexapod. Let's make sure we're on code simple. Okay, and upload. Of course, everything I do works first try, so we're not going to get any errors. That's sarcasm, but once this uploads, hopefully we go into the settings page and it actually works. All right. So menu, settings, and look at that. We've got our number test, beautiful number right there. Really, I mean, it should have been -10 to 10. That is a bug. I will fix that. Oh, there you go. Oh, it's a display bug. Okay, that's fine. And our Boolean test, off, on, off, on. It'd be nice if you could like say, make it like yes or no or something, but again, it's fine. So yeah, we can. Okay, this. Oh, okay. So the Rotary. I forgot how this worked. You can't. This just doesn't work. Maybe what this should do, -100, since the minimum is -10. Maybe what this should do is just make it go down to the minimum. But as of right now, that's not what happens. But anyway, yeah, we can select our number. 4 is an excellent number. Press the rotary encoder in. Value's there. Now, you may be wondering, well, what happens if you turn it off and turn it back on? Unfortunately, nowhere did we edit the saving of the values. So you can see they go back to the defaults. This, however, does save. Okay?
Why? Well, because there's actually code to save it. So let's go over that code. If you want to make your settings save, our new settings, number test, Boolean test, if we want those to save, there's a couple things we have to do. Let's go to globals.h, and the first thing we need to do is define the address in memory. It's called EEPROM, which this EEPROM is just the memory that saves in the Arduino that you can access. Like, you turn it off, turn it back on, it saves. It's still there. So the NRF address was saved at address 0, which is the 0. And its size is 6. We're gonna do EEPROM NRF address. So this is gonna be EEPROM number test address, and then we also have EEPROM Boolean test address. Right. So number test should only take 1 byte. We're starting at 0. Add 6. I believe it's going to be 6. And then this is going to also be 1 byte. So it takes it's 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. That's 6. Yeah. So the NRF address takes up the bytes 0 to 5. The number test takes up byte 6. The Boolean test takes up byte 7. So this requires 1 byte. This requires, I think this only requires a bit, but I don't know how to do that with this. So it's just going to be a byte. Okay. I don't even think you can do that with this. So we've got the addresses. Now, what is this? Yeah. So now we want to make those values external. Even if you're not saving, you probably still want to do this. So extern int, number test, it knew exactly. And then extern Boolean test. Perfect. Okay. That's it for the globals.h. Now the rest of the stuff is going to be in globals.cpp. Here it is. Load values and save values gets called at appropriate times already. You don't have to mess with that. Man, really quick. When are we saving? When are we loading? That's kind of important. Let's go to main. Okay, we load values a single time during setup. That makes sense. When do we save? I mean, we're probably saving in settings. Yes. Okay. So we're saving the value only after the pop-up is closed. That's it. So just keep that in mind. Okay, back to globals.cpp. So this is where we're saving the values. Now, you can't really just copy and paste this because this is kind of complicated because it's a string. Now, if you're saving a string, then yes, you would want to copy this. But for numbers and Booleans, it's a lot simpler. And where we can look to copy is from actually the Hexapod code. If we go to source and globals, you'll see we have the dynamic stride length, which is a number, and this dynamic stride length is a Boolean rather, and yeah, Boolean 1 byte. Oh, long int is 4 bytes. Okay, so maybe we should. Although I don't think it was a long int. I think it was just an int, which is 1 byte. So never mind. I think. Geez, how many bytes is a normal int? Oh, it's 2 or 4. Okay, maybe we. Okay, well, this is good that we looked at this. We should just make it 4 bytes. So let's go back really quick. This is good because this is what you'll be going through when you're trying to code. If we go to globals.h in the code simple, man, number test. This requires 4 bytes. This is still the same. This is different. So 6, 7, 8, 9. That's 4. So this will be 10. I mean, 6 plus 4 is 10. That's a pretty easy way to do it. This will be 10. So that is correct now. If we go back to the globals, well, yeah, we can see how we actually save. So for something small, for something easy, we can do the update function. For something a bit longer, we'll do the put function. But they both look pretty much identical. In fact, I'm going to ask it because I'm not entirely sure and I don't want to misinform you. What is the difference? Did I spell difference right? It doesn't matter. Difference between EEPROM.update and EEPROM.put, and when should I use them? Can I just always do EEPROM.update? So I'm pretty sure update checks if it's different and then only actually writes to EEPROM if it is different. EEPROM, by the way, you only get like 100,000 writes, which I know is a lot, but still, once you run out, you basically can't use it anymore. Oh, okay, so I was kind of wrong. Update is only a single byte. Writes a single byte to the EEPROM only if the byte is different. Put writes any data. So put just writes even if it's the same. Update checks if it's different, but it looks like update only works for a single byte. And you want to avoid unnecessary writes. Fortunately, we're not writing a ton. We're only writing when you exit that pop-up, and you're not exiting that pop-up 100,000 times. So using put is fine, but it looks like update will only work for single bytes anyway. So I guess if you're using a single byte, if you're using Booleans, you should use update. There's no reason not to. Otherwise, put is good. So let's do this. I'm just gonna copy and paste this. Go into my globals of the code symbol. Paste it down here. Save dynamic stride length. Nope. Save. This is going to be Boolean test. And this is EEPROM. It should auto fill. EEPROM, yep, Boolean test address. And what is the actual variable? It's Boolean test. Right? If we go here, there it is. There's the variable. There's the variable. Okay, same thing here. EEPROM number test and number test. Okay. And again, the reason we can access these is because we're including globals.h, and then globals.h, they're external. And then, of course, the define is a similar thing. Well, define is like a constant. External. These can be changed. This cannot be changed after. But anyway, we go to here. Okay, so now within the save function, we are saving this value to EEPROM at this address. Okay, but we also need to load the value because just saving it is completely useless. And we do that with EEPROM.read. Now, I don't have to reference the code for this one. Literally, all we have to do is Boolean test. Yeah, it's so easy. It's going to autofill for us. Boolean test equals EEPROM.read, and then we read at the Boolean test address. Okay, and same thing for the number one. I'm surprised it didn't autofill. Number test equals EEPROM.read. Yeah, there. Okay, let's see if it works. All right, good news. The fix was insanely simple and completely my fault. The problem was completely my fault, rather. Remember when I said I didn't need to look at the Hexapod code? Well, I did. There are two ways to read from EEPROM. Read and get. Read is 1 byte. Get is everything. So I was only reading 1 byte. Obviously, this is fine for Booleans since it is only 1 byte. But for long ints, for example, which are 4 bytes, well, you can see the issue. So this is the Hexapod code, by the way. If we go back to code simple and globals, you can see AI helped me out here a little bit, even though all I needed to do was go back to the Hexapod code. But if we use the EEPROM.get function instead, it works. I've already uploaded the code. We turn the controller on, go into the settings, and there you go. There's the -2, there's the on. Let's set it to -8 and off. Turn it off, turn it back on. Menu, settings, -8, off. We are good to go. That's it for this video. I highly recommend going through both the simple code and the Hexapod code. Use AI to have it explained to you. Using AI to explain code that already works is really, really nice because you know the code works. So its explanation is probably correct. Now, if you're still stuck after consulting the AI, join the Discord and ask for help there. Now, I'm not going to write your program for you unless you pay me, but I will try to help you or at least lead you in the right direction. The link to the Discord is in the description. If you build this, please make sure to post what you make in the Discord. I love seeing what you guys make.